Okay, I don't know if I'm live here. I'm going to check, but maybe this is the. Oh, there I am. So cool. All right, this is Dave D. Hilster, and I am live. I'm sorry I haven't done this before in this manner, although I just got done streaming a lot of live stuff, but that was done with the Sling Studio. This is done with the regular stuff I do with my. Oh, there I am. I can hear me, so we'll see if we have people coming on. And I would say there'd be perhaps very few because I only have a couple thousand people who are subscribers. It's a Friday night, looks good, and I do have. It is working. I can see it here. I'm here in Boca Raton, 9:30 at night, and we will see if people get alerted and come on in. So, see how that works here. I'm going to take a look at this stuff and see. Yep, there we go. That's it. First time I'm using this. Got a little frog in my throat. Don't know why, but because I have. Oh, 3 watching now. Hello, people. Say something. I'll say something here in the chat. If you guys have any questions, that's what it's here. I'm here for. So, hello there. See if you guys see me. So, and again, I guess I just got back from the CMPS conference with a lot of great talks. We had at least 28 talks. You can see them at youtube.naturalphilosophy.org. Most of the recordings are pretty good. The quality of the switching system I used with the Sling Studio worked out pretty well, and some pretty good talks there. One of the things that we were trying to do was to make it the live broadcast so that people could hear both ways, and we certainly did that. We had the sound system and mics for everybody, but it was an interesting event this year. We had people from all the United States, one guy from Africa, and we actually had one video conference person there, person who went on video, and that was Jeff Yee. If you haven't looked at his stuff, go to I think it's energywave.com or org or something like that. You can see it down below on my channel. But very grateful to have hey, there's somebody. Hello there. One of the things is that one of the reasons I started this channel was because during my years of filming Einstein Wrong, I noticed that when I had conversations about that, because people found out I was making a film, that was from 2005 to 2010, it was 10 years. And people found out about that, and so they get in conversation, what's it about, and all that stuff. And inevitably we get around to, well, they wanted to know what was happening. Well, what's wrong with Einstein? What are you talking about? What are these people? And it turns out that a lot of the answers that I gave people in my discussions, people really were very pleased with answers that I was giving. Not because I know all the answers or because I'm a smart guy or anything like that. It's just because, being a critical thinker, I wasn't afraid to say, well, we don't know. Mainstream actually doesn't know what gravity is. Mainstream doesn't actually know what light is. In mainstream, the physics particles that you hear about, all these particles, most likely they don't exist. Well, what are they finding? Well, they have to find stuff because they spend lots of money on it. They predict that they're going to get them, and of course the signals, and that's. And I talk with them about it. They go, okay, if the Big Bang's wrong, well, what do you think is happening? And I said, well, the one of the things I talk about with Big Bang is that people who are know a little bit about the Big Bang. I said, okay, when you look up into the sky and the astronomers, what do we see about stars? Do we see stars evolving? Yes. Do we see stars going through phases where they blow up? They're at the end of their life, and they go, yes. And do we see stars being born in places? And yes, we do that. We do see that. And I said, okay, that seems a little strange to to me, to talk about a Big Bang when we're talking about seeing all these stars going through a whole life cycle. And they think, oh, wow, that's pretty interesting. So, yeah, the Big Bang didn't happen. And they go, well, then sometimes I would discuss with them. They say, well, why do people think there's a Big Bang? And I talk about redshift and, talk about the Doppler effect and all that. But regardless, during my talks with people over the years, I found out that they enjoyed those science talks. And then it turns out that, I'd go to a party and I'd see them again and I go, hey, how's it going? And they'd start, I read this thing. What do you think about that? And so they were really hungry for people who were critical thinkers, who, weren't afraid to take on, things that they thought were strange as well, because you read all this stuff and, big science. And so I just, gave them the answers. And then, of course, I've been hanging out with people since 1992 about, and those people and those scientists started with Dr. Karazani in the early 1990s. I learned a heck of a lot. I didn't come into this talking about infinity. I didn't come into this talking about expansion tectonics. I didn't come into this saying the Big Bang was wrong. The only thing I knew is that I met a physicist from Argentina, and he told me that, hey, I need somebody to help me get my work out there because I've shown Einstein wrong, special relativity, and this is why. And he handed me a bunch of papers, and you can see my bookshelves back here. There's all kinds of stuff I read, and I've read lots of books on all these subjects. And sure enough, I got involved with it. But that was early, before the internet, actually. And then when the internet started coming out, I started taking all his papers and typing them out. Literally, I had an old Apple laptop, and I started typing out Dr. Karazani's work. And then I actually got Dr. Karazani's work visible I was working at TRW in Space Park in Redondo Beach, California, in the Research Artificial Intelligence Department. That's my area. And so I wrote the president of TRW, a billion-dollar company, said, hey, we got this experiment you can do that could show special relativity wrong. And 3 weeks later, I was called to this little office in the building there, and they're sitting in this really small office, very crowded. A bunch of hey Hans, how you doing? A bunch of physicists sitting around, and I had a bunch of papers. I'd made a bunch of copies, and I started handing them out. And they says, well, tell me what you have for us. And I said, well, this is an experiment by Dr. Karazani. He's a doctor of physics, and the experiment is a decays experiment. You need some radioactive material. I knew that actually they had radioactive material in Space Park. Even though I was in a completely different division, they made the lunar lander, I think, nozzle, jet engine that got the people off. And so they had to deal with radiation. I figured, well, maybe they could do this experiment. So I started talking with them, and again, I'm talking about this story for those who maybe have just joined, about Dr. Karazani and his work in my early days of becoming a critical thinker in distant science. And so I handed him the paper, and he says, what's some of the implication? I said, well, one of the implications, there's no neutrino. And somebody goes, wait a minute, I thought the neutrino was confirmed because wasn't it supernova 1987B or A? I can't remember. I think it was A, 1987A. Then that show a burst of neutrinos, so we know those exist. And you know what I did? Man, I was really, how do you say? Well, I've always been that way, maybe. But I mean, these are physicists. I go, oh, so you're a neutrino specialist? No. Oh, so you're a particle physicist? No. I said, you're a physicist? Yeah. He says, okay. So I said, how do you know that the data that they got from the neutrino detectors, because I actually had in my hand, I said, right here are arguments about how that's not true, that the data they're seeing can be explained in a lot of different ways. And in fact, the data they say was simultaneous wasn't at all. It actually came in different waves, And if it came in different ways, why did it? There was a lot of problems. So I listed them. And he goes, you know what he said to me? It was really funny. He said, well, we have to trust our colleagues. So they trust the neutrino people. Neutrinos is just, it was invented. Karazani was brilliant in that. His work on that is just incredible. If you want to read about that, go to neutrinos.autodynamics.org. That's neutrinos.autodynamics.org. I'll put that down there. I'll make some notes here. But anyways, the idea here is if you guys have any questions. Oh, by the way, on the end of that story, what's pretty funny is I asked him if he's a neutrino physicist. We went through this thing. He goes, so you're a physicist? I go, no. And then all of a sudden, everybody looked around at each other and looked at me as if I had just revealed I'm the butler on the ship, and no, I can't steer the ship or fly the plane. And they literally was almost like, okay, give us the stuff, go away, little boy. We don't want to talk to you. At that time, I was, 32. So at that point, I knew it. Oh, this is not good. But anyways, to keep going on the story actually has, I wanted to put this in the film, but it was just too long. The film would have gotten too long, and I'm not sure the general audience would have followed it. But basically, with what happened with that encounter that I had, it was 3 weeks later, I got a letter. I still have that letter. And it was pretty shocking. I got it. And that's when I became a true dissident, because I think it was 1984. But 3 weeks later, one of the guys, I think, took all of Dr. Karazani's work. And basically, what it was worded, it was said this. From what we can see, Dr. Karazani's work on autodynamics, that is a simplification of special relativity, which was basically ripping out the relativity part and making it totally Newtonian. He said, we can't find any problems with that. In fact, I talked with him on the phone. He had said, I'm sending you a letter, but I said, so what did you find? He says, I can't find anything wrong with the calculations. It's like, oh, I'm thinking, well, so then this could be true. And he goes, well, that's not our job, and we've decided we can't do that because it involves radiation. Of course, that's a lie, because I know they have labs and they use radiation. I knew that was. And then the other part was, well, we don't do pure research at this company. We have to do things that are related to business, and that's a little bit more accurate. But that was really the turning point for me, where I go, holy cow, this Argentinian physicist really found something. 9 physicists couldn't poke a hole in it. But of course, they didn't want to have anything to do with it, because I'm sure also the implications. They probably went to the president and says, what's the implications? And I think it was Gorman. I actually remember the guy's last name, the president. Gorman probably says, no, we don't want to touch this. This is too controversial. But that was my entrance into it. And my friend, by the way, with neutrinos, of course, my best friend, he and I have been working together for, oh my gosh, almost 30 years. We came up with a new computer language called NLP++, computer language for human language. And he started, asking about it, because, oh, you're following this crackpot and everything. And it turns out that, in fact, he started understanding it. And he was like one of the biggest neutrino non-fans, bashers out there. In fact, he had his name's Amnon Myers, and you can go to visualtext.org. You'll see the thing actually that my real job is about. But anyways, he said this really amazing story, and that was a story. He made this a phrase up, because what happens with neutrinos is that they were introduced because special relativity. If this is a radioactive material, what happens is you have electrons flying out of this, and just radioactivity. So there's no kinetic energy involved. There's no energy. It's internal to the system, but the electrons are coming out, and those electrons can go up to 0.86 the speed of light. And so, of course, Wolfgang Pauli said, well, if that's true, then we should see more energy than we're measuring. And it turns out 0.36 million electron volts is what chemistry says you should measure. And guess what? That's what they measure. They measure exactly what chemistry says they should. But Wolfgang Pauli says, no. If you want to use special relativity, you must apply it to these decay cases, these electrons going out. And then, of course, what happened was he applied it, and then they found that it's supposed to be 1.23 million electron volts instead of 3 or 4 times the amount of energy coming out. Energy, of course, it's just a concept coming out, and so they postulated that there was a neutron coming out. But it turns out that neutron was taken when Pauli was looking at this. The name of the neutron was taken, so he changed it to neutrino. Well, actually, he didn't. He was talking about it. I think he died, and then Fermi, I believe. Please don't quote me on this, but I believe Fermi was the one who actually named the neutrino. And by that time, actually, Nature wouldn't even publish anything about the neutrino for 10 years. They thought it was totally ridiculous. No charge, no mass. I mean, so it was basically invented to save the special relativity, and that's what Karazani's work looked at, and he sort of reconstructed all this, because what happened is with time in the 1940s and 1950s with atomic bombs, they started trying to measure these, and they said that they finally found some, and the whole thing about neutrino science is not a science at all. It all comes down to they are worried about, if you go to Wikipedia, here we go. Here, I'll read you guys, but let me just finish this thought here. If you go to Wikipedia and look up neutrino, you're not going to see a picture of a neutrino. You're going to see a picture of a muon that used to be a neutrino. I mean, that's how ridiculous it is. And if you really start to investigate it with a critical mind, it doesn't take you very long to figure out this is an invented particle, just like quarks, just like Higgs boson and W and Z particles, all those kinds of things. Things are happening, and what happens with neutrinos is they bury them because they know they can get false hits. So they put them underground, way underground. Look up all the neutrino detectors. They're in a cave. They're in Antarctica. There are all kinds of stuff. And they have this amazing thing about what they call low statistics. I mean, the statistical frequency of finding these neutrinos is absurd. I'm a mathematician, and they actually say that it's okay that the number of neutrinos they'll have like 100,000 gallons of fluid in their detectors. I think that's the one in, don't quote me on any of these, this has been a long time. You can go to neutrinos.autodynamics.org, take a look at it, but they'll find 30 argon atoms for all the triggered events that for an entire month for neutrinos. And then I saw this one program on TV a long time ago. It had to be 15 years ago, maybe even 20. And this guy was carrying this little, literally a beaker, and saying, "I've got to be careful. There are 36 or some 30. There'll be 30 some argon atoms, and those argon atoms are proof that they're neutrinos." Now, of course, if you think about it, how pure can any of the liquids we ever make be? I mean, there's always things coming in, and so why they bury everything is they get false hits from protons coming flying. The sun blasts apart atoms. This is a fact. This is the mainstream says this, and protons come flying at us pretty quickly, and those are what we call alpha and beta particles, because the mass of an atom is the nucleus. And so these come flying through, and those aren't neutrinos. So they try to bury them, and they try to shield them. They keep shielding them. And my friend Amnon Myers, to make this long story come around, he made a statement. He says, the perfect neutrino detector will detect nothing because they will make the shield so good they will not. They'll get rid of all the false hits, and nothing will be left. So. Let me take a look here. I see somebody says, if I make up a particle with different properties and start colliding random particles, is it possible to eventually find it and become famous? Yeah, pretty much. If you haven't read, I have his books here, and he's on my back now. I've got so many really great books here. This one, let's see here. I've got some more here. I'm sorry. I'm looking back here in my, I've got the Lost Keys, but I have another one, which is the Higgs Fake. Here it is. This is a great book. Oh, here it is too. These books. So, Aki, I guess your name is, if you were talking about making up those particles. Here's the guy you want to read on all that. That is, here he is. This is Alexander Unsker, and this is Einstein's Lost Keys. This one, I'm going to be interviewing him live. He's in Germany, and he basically talks about light speed isn't a constant. What? And this one is an absolute great book. I can't believe I want to interview him actually more on this book because I can't believe what he says in here. The way he absolutely talks trash against particle physics and basically says sell it out. And this one's too is bankrupting physics, how today's top scientists are gambling away their credibility. This basically, he's like myself, a truth teller, a critical thinker, and that's really, he talks about this exact thing that you can name a particle. That's what's happened. The Higgs particle. The big one was the top quark. I remember in 1993, 94 when I was working with Karazani already, so I knew it. They came out with a paper. They didn't know they couldn't find the top quark. Whatever that is, whatever signals the signals they talk about they're looking for, which is basically smash stuff together, and if you see the right signal, you found it. And of course you have to do quadrillions of them, because once you find that signal, of course you found it. Of course this is voodoo. But regardless, yeah, I lost my train of thought. But basically these people who are doing this work will set themselves, oh, it was the top quark. And they actually came up with a paper and couldn't find it, and they had over 900 authors to one paper. Now, it took me many years to figure out why they would do that. And the reason is they all wanted to have a key. This is the reason. The top quark had 900 people in the paper who described on how to find it. Why? Because that way 900 people would be famous. And 900 people could all say that I was part of finding the top quark. Of course, it's all garbage science. It really is. What do you think about quantum physics? I haven't talked much about it. In fact, my dad's book, we are working on it still. We're coming up with new titles all the time. I wonder if I can find an old copy of it stashed around here. Oh yeah, look at this. I got some, we do versions of it. Here it is. Boy, these are old. Look at this. Universe, a particle model of the entire universe. This one too. Actually, we have a totally new cover. I've been working on the cover, on the marketing of it. We're working on how to write the beginning of it over and over. The reason I'm talking to you about this, about quantum mechanics, is that we look at the double slit problem. Quantum mechanics comes in a lot of what they call quantum mechanics comes in when they talk about the double slit and particle wave duality and particles that are spooky action at a distance. And actually we have several solutions to that. And what happens is that quantum mechanics has turned into super voodoo. I want you to take a look at Hans Adam Plast. Hans, look up this, okay? Look up history eraser experiments. Now, basically what this states is that because when they send photons or electrons or whatever they're sending through these slits, and then they put a detector next to the slit to find out which slit it's going through so they can see, and they say it's sort of like it's in two places at once and those two particles know what's going on. Well, this has led them, because of these assumptions that this actually happens, which it doesn't, they actually come up with these crazy ideas that that's why you will see articles that will say there are people giving lectures about this now, that things don't exist unless we see them. And in fact, if I'm the only one to look at a photon, I'm the one who affects that photon. And yes, the history eraser experiments are, here's a star, let's say it's 3 billion light years away from us. So this star, and so what happens is you have this photon coming around, and it could come around this way or this way, because of course light is bent by gravity, which of course we don't believe at all. but let's just say basically it's being bent by the corona of a sun because there's mass there. It's just like water. You stick a stick in the water, it looks bent. So that comes around. But the history eraser experiments say that if I look at it with a pair of binoculars and you look at that photon with your naked eye, that what will actually happen is that it could go in two different places, and they couldn't figure out how to solve that. So quantum mechanics and these people who are talking about quantum physics all say, well, what it is there's a collective that, okay, things don't exist unless we have intelligent beings looking at them, and there's this collective heads all around the universe, all these collective intelligent minds are sort of summed up somehow, and that will make sure that the photon's only going to go on one side. It's that bizarre. It all comes down to this slit, and it all comes down to that they don't have a model for light or gravity so they don't know what's happening with the slit. We have actually in our book we have it. My dad's talking about. I think you may have talked about this. You guys need to subscribe to it. I know he's not the most exciting speaker, but he's talking about our particle model, and we basically light to us is just groups of particles. In our model, he solved the wave-particle duality. He has a solution for it. Whether that's the solution for it or not, time will only tell. But it's the only one I've ever seen, and that basically we can describe the entire experiment very simply. And but quantum mechanics is totally lost because they make these interpretations because they don't know what light is, they don't know what gravity is, they don't know what an electron really is. Look up the electron. There's really almost no, what they say, one of the guys at our conference that we gave the Lifetime Achievement Award, he's actual particle physics. He's a really brilliant guy. He says the way you test for particles is that you can shoot a beam of them. So if you can shoot a beam of electrons, then there's an electron. So that's, basically. And of course, in our theory, we say, well, light goes at the speed of light. Gravity goes at the speed of light. There's a couple experiments that show that during an eclipse. And electrons seem to go at the speed of light, at least around the nucleus, goes very fast. And of course, in circuits, they go pretty close to the speed of light too, even though the models don't work out that way. So we have the same. It's all the same particle if it's going at the speed of light. But again, the solution to quantum mechanics is that you throw it out, all these assumptions and all these crazy things about history erasing experiments, because you have a physical model and you can explain it. There's even another guy, his name's Eric. He asked me about his lecture. I got to get it online. It was in 2017. We had audio problems. We're a small organization when we come together. Excuse me. And so he talked about how you can even describe it with regular physics. That what they're saying and they're describing is crazy. It's sort of like the redshift. Or dark matter, the redshift in quantum mechanics. There are real obvious ways you can explain this with regular simple Newtonian physics, and they don't seem to be interested in that because that would be too easy and they couldn't fool us. So, okay, that was talking about what do you think about quantum physics. I will talk more about that as we go on, and hopefully our book will come out and give it one. It says draft science. Why doesn't light hit light? Oh, it does. It does happen. Anyways, I'm going to the next one. Hi, David. Adam Love. What do you think of stellar metamorphosis theory? I'm not really familiar with that. Okay, he says right here, the idea that stars eventually become planets and the Earth is really an ancient star. Actually, if anything, if there's something like that, I think it's the opposite way. I'm not sure I really subscribe to it, but it certainly makes sense. The idea that gravity is a Newtonian, it's a push. Everything in the universe is, at least that's what I believe. And therefore, if you push on stuff, the Earth has been growing. The Earth geology points to expansion and also mass increase. If you read Stephen Hurl's book, he'll talk about that. And so if you look at it, actually Jupiter, if you look at all of its moons, some of the theories, some of expansion tectonics people will say that Jupiter is going to ignite sometime, and as it's getting bigger, and the moons around it are getting bigger as well. In fact, if you got to look at Ganymede, if Ganymede is actually expanding, and it's actually said by NASA to be expanding. They're not saying that it's why it's expanding. They're trying to come up with some ideas, but the mechanism of gravity or the mechanism of simply blowing atoms apart and then coming in on the poles. Dr. James Maxwell is talking about that, and a lot of us do talk about it. In fact, I think because the magnetic field is actually particles that are going around. If they're entering here, if you look at a globe, you'll see that actually the globe, you have a lot less land here. But the idea is that, well, you can see it. You can see the expansion on here. In fact, when you take the expansion away, it all closes up. Some guy calculated that it would be 96 quintillion of a chance to actually have that happen, that they would, if you take away the seafloor bed every 10 million years strip, that all the continents literally come together on a smaller orb. The chances of that are 96 septillion or something like that. So actually, from the people I've known, it looks more the other way. That actually they say Mars only has a little water. Well, the water's coming. It comes through. It's coming through the smokers at the bottom of the ocean. Water's manufactured inside the earth. Oil's manufactured inside the earth. In fact, mainstream science in the last year, look it up, they find water in diamonds that they know are way too deep for it to have somehow seeped down there. So mainstream science is starting to say, hey, they literally saw an article, mainstream science, that says maybe water is manufactured inside. So my feeling is there's more chance of that all the bodies are expanding. Of course, you have nuclear happenings with stars, and that's a whole different process. They're not putting it's a whole different process, but that's what I would say on that. Aki, are there any current research into origins of light, gravity, or is Einstein pretty much accept 100%? Well, I think that's first of all, I don't think there's any explanation of the origin of any of that stuff. So if you're saying the origins of light and gravity, mainstream science doesn't talk about that. I remember hearing Dr. Andreas Cies, who's a physicist in Brazil, who talked about he's follows Ampere and Weber. That's, if you want to look at his books, it's really fantastic. Let's see if I have one here. Experimental Histories. No. Archimedes, the Surface of Gravity, and the First Law of Mechanics. I think this book may have it. You look up Andre Assis. He has these books. Some of them are in Portuguese. I do read Portuguese. Like this one here, Archimedes in the Center of Gravity and the Lay of this one here. It's in Portuguese. So, but anyways, what I would say is this. He said, and this has been stated, that gravity is a field of well, we believe it's a field of particles that are flying around in all directions, and those are blown apart. Well, gravity, light, electron are all the same particle, and they go around the nucleus. So when they get blown apart, they get shoved out from, stars are blowing these things across the universe. And so the origin of them are stars. They get, stars. What happens is it's a cycle, basically. The G1 particles, what we call G1 particles. And there's infinite levels down, but the G1 particles are blown apart and they come from sun. So what I would say from the particle model and other people like Andreas Cies, that actually the origin of gravity and light comes from the stars. They're blown apart and then they come back into matter and gather up and make the Earth expand and all those things again, and then they eventually get bigger and bigger. Jupiter, like I said, if you look at it, it looks like a mini solar system, and eventually those gases, something will ignite. It'll get enough. Because it's gathering mass at a much faster rate. So, anyways, and that's one of the reasons you have perihelion advance. Because the perihelion advance, they say, is special relativity or general relativity, but in fact, if you make mass increase, Mercury, the perihelion advance by mass increase will be explained not only for Mercury but for the other planets, which I think Karazani calculated for Venus, Earth, and Mars. They only calculate for Mercury because it only works for Mercury, so it's very convenient. You don't see them calculated for the other ones. Let's see. Are there stellar? Are there current lights? Okay, what do you think about the future of quantum computing? Well, basically, because I'm in computer science myself, basically all they're doing in quantum computing isn't quantum mechanics being shown to be right. Not at all. Quantum computing is basically people doing things that are other than one and zeros. Right now, we have just transistors and states in solid state silicon, which we make that can hold in this case what we would call charge, or like G1 particles or electrons in a certain place, and those can be released and read, that kind of stuff. And so basically quantum, they call it quantum computing, but in reality it's just non-binary. So if you have states that are non-binary, you're going to be able to hold, instead of ones and zeros, a lot more information. And that's why you can say, oh, quantum computing is going to hold a lot more. But they've hijacked the word. It really doesn't come from, shows nothing about that kind of thing. So let's go forward. I'm sorry to cut the live gig. Yeah. Hey, Lisa. Hey, thanks so much. I hope you saw the last video. I had your comment in there. It was really super. In fact, you gave me the whole idea about science woke, and then people in the comments says, people are calling you the Bernie Sanders of science. I said, I don't care what they call, because my goal is not to be, if the only thing of fame, I tell people, I'd like to be famous, not because of the ego. That means nothing. It means that's like putting a value of somebody more on one person than another. It gives you power to do stuff. Then I could start a university of critical thinkers, maybe, get some heavy investors and, build a building and actually say, guess what? When you learn physics, you're going to have to look at all the different aspects of it. You're not going to be told the truth. So when everybody hears that, when mass increases to, as you get closer to the speed of light and you say mass increases, and Dave D. Hilscher, or his dad in 1955, raises his hand at University of Michigan, says, hey, professor, why is that? Give me a physical reason. They goes, well, we don't have one. Then they can discuss that and say, well, maybe this isn't a good model. So but anyways, it's really great to get this idea out. I have some ideas to get it even out more, but we've got to get our websites in order so that when people land on Critical Info, we're working on that right now. We've got a really great website. I'd love to have anybody help out with it. Basically what we're doing is, anybody, in fact, if you don't know a whole lot about what we're talking about, that's even better, because we want to make sure when people land on this is really a marketing site. You're going to look at it, it's going to look, you're going to find interesting stories about, blow my mind on each of the scientists and put it in a really interesting story about them. We're going to put mainstream problems like, redshift. Is that really because everything's speeding up or expanding, going away? Or is it because of like light, the nature of light? Because light, this idea that something can go infinite at the same speed. Have all those things there in a really fun way, and then have new theories and different ideas about what people are doing and get them hooked into this as critical thinkers. Then we have our Wikipedia, and we have our university that we're starting. We're going to be starting to write courses in that university for critical thinkers. Well, great to see you, Lisa, and thank you for answering my question. Very interesting. Okay, Adam, very nice. My brother is visiting, and just today I showed him the animation of Spanning Air. That stuff blew my mind. My mind's been blown only four times in the 20 years I've looked at stuff. The first time my mind was really blown was Borchert's work. I read his book, Universal Cycle Theory. Here it is. And actually, I don't like the universal cycle theory itself, but the neo-mechanics in this book blew my mind. This is where infinity and all the levels of, he does ether 1, ether 2, ether 3, because you have a real problem. You can't have an ultimate particle of the universe because you got to give it magic. So particles, that blew my mind. I read that book and I called him up and talked with him an hour. I said, from then on, I said, you're down in history with your work with infinity and all that stuff. The second thing that blew my mind was Yonel Denou. Yonel Denou, look him up. Yonel is Ionel, Denou, Dinu, and look up the underwater experiments. It'll blow your mind. Basically, he shows that swirling water around like a cylinder, like this is a cylinder, swirling water around the cylinder in the same direction, opposite directions, two swirling cylinders act exactly like a magnet. And so when my dad and I have that in our book, in fact, I probably have in our book a model of that where we try to explain it. This is the bad explanation because we've been on. Here it is. So in our book, see that really? I actually write a program to do that. But those are all those little dots are actually two swirls of particles going around and around each other. If they go in opposite directions, they attract. If they go in the same direction, they actually collide. And that was somebody about, I think it was Draft Science who talked about. Hey, Draft Science, here we are, the tinfoil guys. You know, the ones we talk about dead people. Anyways, let's go forward. Let's see, my brother's visiting. Okay, it says, do you have any beginners videos? Yeah, we're working on that kind of stuff. We're working on that for the courses. We're going to have an overview. In fact, Lisa, if you're interested, you can help us work on that, and I'd love to have you do that kind of thing. But what we're using is Easy Class, easyclass.com. It's an open source learning. I'm going to go look it up here. See if I can look this up. I'm sorry, I'm not going to show it to you because it's not public yet. Actually, you can see a little bit of it. I'll tell you a secret. If you go to my introduction to the CNPS, I actually show screenshots of what that is. So those people who don't like me can go out there and pretend to beat that up. But let me see if I can get in here. And I'll tell you. Oh, I know I need to go to the university. Easy Class. I was talking about Easy Class. Now I forgot what I'm going after. Well, it'll come back to me. I was looking something up, but anyways, we will be planning to make some of these. Oh yeah, the learning systems. So there's these learning systems, easyclass.com or .org. Take a look at that. We'll be making these things. Absolutely. You know, my mom was a lay person, and she actually sat down with me. It was like the first day we went to the NPA conference, which is what we used to be called. It was in 2006, I believe, or 2005. And she sat down. Okay, I've heard enough about this. Tell me what the difference between special relativity and general relativity is. In fact, Lisa, if you have class questions at a basic level, I can certainly give you those. And will certainly... actually, I could make some. That's a good idea. I could just make some of my videos on that, on sort of the basics of stuff, and just that could be the basis for this kind of thing. Okay. Do you have any thoughts of Mach's principle? I've heard different interpretations of happening hypothetical universe with only two. I'm not super familiar with that. I used to know about it. Maybe if you could, if I looked it up a little bit more, I could take a look at it. But a hypothetical universe with only two objects. I will say something about that. I did a video which was something that I really thought about a long time, and that are the thought experiments that Einstein has. Einstein, this is a little history for those, like Lisa maybe, who's just beginning out. Einstein's whole idea that gravity and bent light was the idea that if I'm in an elevator and that elevator is moving, and let's say it's going up, and it's in space. Let's say there's no body around and it's going up in space. It's moving. I'm going to feel as if I have gravity, and we all know that if you rotate stuff in space, you have that artificial gravity, that kind of stuff. And he was saying, hey, look, we have a problem here because without any kind of reference, I don't know if this is gravity. I don't know if this is I'm in space. Then if you're on the Earth and the elevator's falling down and you're falling at the same rate of gravity, you think you're floating, you think you're in space. And then of course he's saying, well, if I put a light beam in there and that's the way, then that light beam will bend, and therefore gravity bends. That's how he got his idea. Now, I came up with one, if you look way back, I believe, not too far back, but I've only been at this a year and something, is that we have, I made something I call that thought experiments that people have, that Einstein's thought experiments are impossible. And the reason is, and it has probably has to do with something that I think this is the idea with Adam Lohr here says Mach's principle, and you only have two objects. The whole thing about the universe, it doesn't work that way. If you read Borchert, I'll give you an example. If everything's held together by some fields, and now again, what you call them or whatever, we have little particles as fields. I mean, these electrons or light particles or gravity particles, they're traveling all different directions. Well, if you get to the edge, like if you get to the edge of the galaxy, you have some of those are being blocked. That is, if you have a galaxy, what can I do with the galaxy? Here we go. Here's a box. It's a flat box. If you have a galaxy, this is a galaxy, you have these particles that make gravity. You have a field of gravity. Well, along the edge, the gravity field is different. And that's one of the talks my dad gives. And because of that, you get the different velocities at the edges of the universe. So you have a galaxy, and it's got different things in the universe. Well, what happens is if you have the universe and it's only a big bang and it's moving outwards, one on the edge of the universe is holding anything together because things are held together because of things around them. Bigger things hold littler things. Gravity holds our planets in place, our sun in place, and then we have actually G2 particles at a level down holding the G1 particles that go around the nucleus. All these things, all these fields that are made of particles, all the way up and all the way down. Well, what happens is, and when you look at an experiment like Einstein, he's getting rid of everything. I used to do this. I used to say, okay, I'm going to get rid of everything in the universe, and all I'm going to have are two people, and one's going to be moving and one isn't, or they'll have a relative movement, and you can say, who's moving? Well, the problem with those kinds of experiments is they can't exist. You can't have nothing in the universe and have just two things appear. If you read, you got to read Borchert's work, and again, these kinds of works are not that hard to read. Actually, if you read the Universal Cycle Theory, there's parts of that book that are just talking about infinity. You can't have something. Everything affects everything. Basically, that's all it says. This whole thing that a butterfly flops its wings in Africa, and that then eventually adds to what's going to be a cyclone or a hurricane that came through here last year in Florida. Well, all those kinds of things, everything is affected everything. So if you do all these experiments where you only have two things in the universe, we have a model of the universe, and it's got to have everything. It's got to have things all above it and all below it and all around it. It's infinite. Because if you don't, on the edge, what happens? Those things disappear. If you have a big bang, it's all going to go out into space. They have to come up with a big crunch. So you have this philosophical problem when you only make these experiments with only a couple things. That's not the way the universe works. So you're making up a part of the universe and you're saying, well, we don't have that. Well, I don't want that in the equation. You can't do that. The universe exists, and everything in the universe exists because of the macrocosms and the microcosms around it that all support the system. And that's why if you think about it, if this is the ultimate particle of the universe, it's not going to do anything unless you give it magical powers to organize. It's got to make atoms at least, or something like that, or subatomic particles. It can't do that without any types of. It's just like, what is it? A being with if it's got smaller parts, then it's not the smallest thing in the world, in the universe. So these things, this whole idea of experiments where I used to put only these two things in the universe, they can't exist. The universe doesn't work that way. In our model, it falls apart because there's no gravitational things that if you don't have those G1 particles, you don't have atoms. Atoms can't be formed. So that's one of the sort of an answer. But again, if you want to talk about Machian stuff, I know who talks a lot about that is Andreas Sies. He's very good. How could supply you with all kinds of questions? I know that much. Oh, right, that's cool. Absolutely. Because absolutely. In fact, Lisa, if you want to send me, I think I'll be able to do it, because the one good thing I'm a systems person. I'm not a detailed person. I'm more systems, and even in programming, I always have to hook myself up with a person who's super detailed, who doesn't like blank slates. I like blank slates. I like to come up with new systems. So Coming up with some beginners videos on talking about this stuff. I know how to do that a bunch because my mother, rest her soul, who was in my film, was exposed to a lot of this stuff and was very interested, and she started to get it. So that's very good. Let's see, how are we doing? Oh, there are 7 people still watching. Well, anyways, what time is it? 7:20, coming up to about an hour. Well, I really appreciate it. Having 7 or 8 people watching is actually quite good for the number of people I have as subscribers. Like I said, I got a letter from an email from high school students from Nepal. Actually, I read that at the conference. I didn't want to record that because that was a private email I got from these kids, but they're the ones who really set me up with this, putting up the, Lisa, go to youtube.naturalphilosophy.org, go to CNPS 2018, go to my introduction to our group, and in there I actually have slides of the university and of the CNPS, and they are meant to deal with people who want to learn about science through critical thinking eyes, and that's quite a an amazing thing to have, I think, for all of us. So that's I definitely want to work with you on that. Maybe even work on the site with you if you have time. We can get you a login, and we'll just start looking at these things and saying, okay, and if we can explain, sort of use, I'm sure you're a very bright person. I don't believe in titles. I don't think today and age you can go on the internet and probably almost become anything, even a doctor or a surgeon probably. But regardless, I'd be happy to make. But what I'd like to do, Lisa, is to make these steps so that they are out there, that anybody can get at them, and that's why I made this university. University.naturalphilosophy.org. But I'd happy to have you look at part of that. Adam Lohr says, Unsker is big on Mach's principle as well. Thanks for answering that one. I largely agree that you can't have that kind of imaginary scenario. Yeah. I mean, I used to really think about it because it was an easy way for us to sort of simplify the universe and therefore come up what I was thinking would be the sort of laws of the universe. And the truth is there are no laws of the universe. The universe works the way it works, and we impose laws upon it. We say, for instance, the speed of light is constant, which it isn't, and there's actually lots of evidence not for that. I know in GPS they even do c plus v. This is an interesting lesson for you, Lisa. Is c is the speed of light. So we talk about c a lot. And c is supposedly a great constant in the universe. And constants in the universe really don't exist. They're sort of our way of pinning something down. For instance, my dad likes to tell this story. If you watch his video on CNPS, my dad's videos are quite easy to understand. They're not. So this is a ball of whatever I don't know what it was, iridium. I don't remember. That's probably totally wrong. It's I don't know what it is, but they have a kilogram standard. So they make this cube or this sphere or whatever, and they basically, my dad says, is all right. They take this and they say it's this big and all this of this size, and they with a Sharpie on there or a marker, they go 1 kilogram. So 1 kilogram, that's the way you define it. The same way with the speed of light. The speed of light is what we are measuring on Earth. And here's an interesting fact for all of you. Can't remember his name. Barry Sutterfield. Look him up. He actually did something, and he gave a talk in 2015. Go to this is a good one. I need to get this one in Barry Sutterfield. He actually shows statistically that the speed of light has been speeding up. No, slowing down. His first measure was over 300 kilometers per hour. And it turned out, I always thought when I saw that, it was just that we had more precise instruments. It turned out that's not true, that they measured the speed of light over time. In the last 400 years, we actually have hundreds of measurements. And those measurements show a clear change in the speed of light. So what we call constant, the speed of light. Well, it's supposed to be constant, but of course, I was talking to you, Lisa, about c plus v. What does c plus v mean? Well, the speed of light can never have plus v, plus a velocity. Because Einstein says, as one of his postulates, as one of the things he said, you can't go faster than the speed of light. Yet, in GPS, they use, here's the satellite, and they do a signal, and it's moving, so they do c plus v, c plus the velocity of the satellite. This is absolute fact. And on the way back, they do c minus v. You know what they say? I'm not kidding. This is not a lie. They say, well, it averages out to c. This is mainstream science for you. So, C, that's your taught today. And of course, this Einstein's key, and you can get these books, Lisa. They're not hard to read. In fact, even the Higgs particle, yeah, it's got stuff in it, but he talks a lot about human nature and why people spend their time looking for things that don't exist, and they may know that. So in Einstein's Lost Key, he talks about a variable speed of light. So there's one big problem in mainstream science. You hear it all the time when you go to school. Light is constant. Light is speed is constant. So let's see here. It says, Lisa, I read some Richard Feynman's books. Good. He's pretty good. He tells a lot of truths. Because even though I didn't understand hardly anything, he was entertaining. Yeah, I looked into it. And Nikola Tesla. Nikola Tesla's interesting because he does things. The only thing that with critical thinkers that's interesting to us is that, like my father and I's models, we try to explain why, for instance, he was trying to transmit power. Why the way he was doing it wouldn't work, because we have a model of light and gravity and electromagnetic waves and magnetism. And the model's working very well. It can describe, in fact, one of the courses we're going to have in our university is explaining the electronic components in circuits according to really what's happening, because all the equations the electrical engineers use are not physical models of the universe. But anyways, Nikola Tesla was trying to do things that, according to the models that we are making of the universe, these new models, he was trying something that wouldn't work. And it's an interesting story. It's just like Stephen Hawking, but Stephen Hawking didn't even he didn't even get close to getting very many awards, because even the physicists around him. But to answer your question, Feynman, not too bad. Stay away from the physics evangelists. Stay away from, especially Neil deGrasse Tyson. Guy is super arrogant. Watch my video. I think it's my third most watched video is called Tyson, Arrogance Incarnate. The guy is so arrogant. When they asked him if could Einstein be wrong, he laughed. And he says, it's been proven so many times. He says there's facts, and once you get to them, they're written in stone. You can't say that as a scientist. You go to NASA, go to SpaceX now and say, this is the only way to do this thing, this rocket stuff. They're gonna just fire you on the spot. So this whole idea that there's only one way, I know one of the people here in this chat today believes that there's only one truth. That's not true at all. So, but anyways, that's my idea. Einstein Lost Greek. Just read recently that one. Yep, that's good, Adam. Not too many equations and stuff in there. That's true, absolutely. But Lisa, I'm just so happy. My goodness, this whole idea of teaching. We've got people who are homeschooling their kids that are like they don't want them to teach this stuff. My daughter brings stuff home. It was funny. I was talking to Ray Gallucci. Ray Gallucci is a fantastic scientist. He always says he doesn't have a theory of his own. He doesn't. But what he does is he takes theories, he takes mainstream stuff, he takes he hasn't done it with our theory, because our theory is pretty new. Our model's pretty new. And we didn't come up because we wanted to. My dad came up with a solution, and I put stuff together. It just happened, and that's the way it happened, and we didn't sit around looking for it. But Ray Gallucci is always looking at these things, and I was talking to him. He had the same reaction. When you become a critical thinker, Lisa, what's going to happen to you is you're not going to be able to turn on Discovery Channel and watch one of those things about the universe without just pulling your hair out and turning it off, or throwing a brick at your TV. because they just talk about this stuff as if it's right. Oh yeah, the Big Bang and the redshift tells us this, and then of course then we have this, and then you go into this stuff that's totally magic. It's just magic. You're thinking to yourself, if I'm an engineer, I'm looking at this stuff. This is stuff. There's no way this stuff is right. So that's one of the things you're going to find out as you become a critical thinker. My daughter brings her book home. Let's say this is a science book, and she's reading it. And it goes, she says, Dad, I know you don't agree with almost anything in this book, but I got to learn it for school. How sad is that? I mean, how sad is that? But it's right. You were the one who said, hey, there's all these other wokes. That's why I put that last video up, because there's politically woke, there's racially woke, there's economically woke, there's ecologically woke, environment, there's health. You know, I'm on a whole plant-based diet, reversed my heart disease. They said it was genetic. You know, that's happening now. You know, the vegan movement, or the non-meat, the no oil, no all that kind of stuff. And then why isn't science? Yep. The problem is, Lisa, the trick of it, that's what I said in my last, I hope you watched my video, Are You Science Woke, is that this whole thing with Trump and this anti-science, and all these people are throwing away, they don't believe in science anymore, is completely putting a smoke screen over all this stuff, which they are starting to get nervous about. It used to be there was no mention of even Einstein being wrong, or no mention of these ideas, but we're out there enough now, and we're growing and growing, that it's starting to bother them. And so they're really happy that the politicians are trying to get this, you know, the right against the left, and the right doesn't, you know, wants to pull. They don't want science because they want profits to do whatever they want. So that's all part of this whole game. So. Says, yeah, my son was unschooled. He was one of that told me about Tesla and how he was ripped off. Yeah. I mean, unfortunately, there's a lot of problems with that kind of stuff. And the really sad part, Lisa, is that you get a lot of stories of people who were drummed out of. I've got story after story. Luis Salomão, he was a Brazilian. He's a Brazilian of art. He's in our group, doing great models of light using particles, like what we are doing. And for 3 years, he was teaching his engineering students that when they picked a subject like the Big Bang, they were required to look at arguments against the Big Bang. He did that for 3 years, and I wanted to use him as a model. What are you doing? How are you doing this in class? And he told me on the phone, I was talking with him, he says, Dave, I can't do this anymore. A third of my students are going to the other professors in physics and say I'm teaching bad science. I mean, there's story after story. Stephen Crothers, who has ripped apart the mathematics for black holes. He's gotten people at Ohio State University who are black hole experts to send him a private email saying, this is not public, please don't say this, but we haven't found evidence of black holes. But come to see my talk of black holes. I'm going to be in Australia, in your country. Come see my talk on black holes, even though we haven't found the way that we thought they are there. And it just goes on. Bill Lucas made a criticism of Einstein. 2 students from Karazani tried to do his experiment and said, we're literally told, you want to have a career in science, don't do these experiments. I mean, what kind of world we live in, you know? Let's see, had a chance. Okay, the Tyson in person, similar question about the Big Bang. He was not open to any alternatives. It was very condescending, arrogant. I mean, when a guy has a T-shirt, I mean, can you imagine? If I start selling T-shirts with my picture and like a halo around, he's actually got people selling T-shirts with his head with a halo. Of course, I have a really nice one. Go to memes.naturalphilosophy.org. I made one of the Last Supper with all these guys. You know, we worship these guys. There's no such thing as genius. Genius is an idea we came up with, thinking that they're super brains, but they're not. Even child prodigies just get to adulthood faster. I mean, yeah, they graduated with 12 years old, but they don't become 10 times smarter than everybody else later on. Where are they? So that doesn't work. So Lisa says, I already can't stand any of this stuff on Discovery Channel or anything about space that's discussed in mainstream. Yeah, it's pretty sad. You know what's really sad? You know, one of the things I'm hoping, because I actually have some ideas. I've got an idea, because I lived in L.A. For 25 years, so I hung out with a lot of people who are pretty creative, and I've got a concept that I think could actually bring millions of people to this subject, but we're not ready because Lisa, if I'm going to turn on the spigot for 100,000 or for 1 million people or subscribers, we're not ready. Where are we going to send them? Criticalthinker.info. If you go and see that video, see part of it. And university, it's not ready. I wish I had some rich donors that could pay me a six-figure salary every year to do this, and so I can I don't need to be rich. I just need to be in my place with my family and work on it. I could work on it, but it's all done by volunteers. So, it's depressing. It's good to know. I think I'll probably do one of these, take one of their series and rip it apart a little bit. Excuse me. Well, one of the things I don't know if you've known this, I did actually have a standing interview with a big site. That's not one of the ways I'd turn this on because I'm not sure it's a good way to do it, because they want to take one of the videos or my videos and then do this sort of like Science 3000 where they sit there and sort of try to tear it apart, or my movie, for instance. And I think they're gonna miss the idea. So, but one of the guys that guy talked with, I had pre-interviewed for being on his channel because he really liked it, but he wasn't sure the people who were doing his channel would like it because they're going for big views. They're not interested necessarily in their idea is to tear apart things that are like the flat Earth. Well, it turns out that secret, the people who are in the flat Earth movement, none of them believe the Earth is flat. This is a grand prank that they're doing. This is just the fun and games that they're doing, and they're trying to take it to the limit. So their whole game is how far can they go? How many people's feathers can they ruffle? And of course, people are picking it up on the right, on the conservative side, and saying, yeah, look at this. These guys really don't know science. This whole thing about climate change, and the truth of the matter is, when it comes to climate change, we got to look at the data. All of us have to look at the data. I haven't looked at the data. They say it's all this way or that way, but I'm even skeptical. I'm not saying that we are destroying the planet, believe it or not. 51% of the greenhouse gases come from animal husbandry. The crap that from raising beef and cattle and pigs and chickens is going down the Mississippi into the Gulf, and we have a dead zone now in the Gulf of Mexico that's huge. We are, that's what we should be worrying about. They want us to worry about our cars, which is maybe 12%. But regardless, we all have to be critical thinkers, even on that side. Even the liberal side, I'm a progressive, complete progressive. We have to look at the data and make sure what we're saying is true. Because that's one of the problems. If we go out there and say climate change in the cycle we're in right now is caused by, we got to make sure about it. I'm not denying anything. I'm saying we have to allow all sides to look at it. So, well, let's see. I've been questioning everything. Flat Earth. There's Riddick Cerny. The FE PSYOP is trying to discredit the truth community and all critical thinkers. I'm not sure what FE is. Can you tell me what that is? Sorry about that. What is FE? Sorry. Well, are there people doing stuff out there? Yeah, I'm not sure it's happening in science so much. I think what's happening in science is a little different from like politics. Politics, people are killing people. That's true. If you look at the data, people are conveniently disappear when they have to testify against Clintons. I'm not a conspiracy person, but I never looked at it. I looked at the data, and I started paying attention to it, and it was like, wow. Oh, Flat Earth. Thank you. Flat Earth PSYOP is trying to discredit the truth. Maybe, Radek, it could be. I don't think so, because the people I know that interviewed me who know these guys say it's much more of just an elaborate prank. I don't think the people who have so much money play at that small of a level. I think they go way higher. And the things with science, it really comes down to the atomic bomb. The reason they build these colliders and they look for these particles is because they're afraid, Europe's afraid the United States will come up with the next particle and then have a bomb that can destroy the entire planet, and we'll be the most powerful. That's why they do it. That's why they built the collider. They didn't build the collider. You think that the European Union and the politicians built the collider because they're interested in the fundamental facts of the small particles, the subatomic particles? No way. They're interested in coming up with the God particle, and if that turns out to be powerful, then they've got it. That's what drives it, in my opinion. Yeah, it's really hurt. It is. I mean, I will say that the who's funding the prank? The pranks doesn't need very much funding. Basically, it's just people getting together. I mean, how do we make a university? We're going to make a university. You can make a university online for almost nothing. Just time. You just put into it. It's time. Type it in. You put it up. Sometimes once in a while somebody has some money, so they'll make some type of thing. But today and age, things are cheap. You can do things cheaply. So the people who are pranking it, you know, again, that's only because this particular group does that kind of stuff. So they try to find and talk with these people, you know. But it is hurting people, absolutely. Like I said, the politicians saying there's no climate change, and again, we have to look at the data. The data that it is. Some of the people, very many of my I'm a liberal progressive person. A lot of us, and I have friends who are completely on the other side, who are creationists, who are scientists. I don't judge a person by their religious views or their political views. But what's happening is the politics on both sides are ignoring all kinds of stuff. So, and that causes a smokescreen. You know, the alt, you know, the fake liberals or the fake progressives are saying, oh yeah, well, it's 99.99% sure that climate change is happening. Well, we've had cool downs and heat ups all the time. So polluted is different. Polluted is absolutely different. Anyways, well, again, I don't know if it's. Here's my take on like people doing, you know, eating stuff and being sick. 9 out of 10 people die of diseases that are caused by what we eat. But it's not the poisoning. It's because our bodies are frugivores. You look at, go watch Cowspiracy. Watch Cowspiracy, What the Health, Forks Over Knives. Take a look at it. Basically, we're frugivores. Our intestines are not made, and our teeth are not made for putting, intestines would have to be a third of the size because meat goes pure. So what happens is the people who make money got into the mechanisms of making us eat stuff, and they sell it to us. They know it makes us sick. The people who are the diabetes know it makes us sick, and they had to change because these documentaries are exposing them. So now the Diabetes Association, just in December of 2017, put on the diets that are actually don't cause diabetes. Before they had all the diets that cause diabetes. This is a cycle of not control. It's more of money. They're just greedy. People want more money. That's all they want. It's greedy. In terms of the flat earth, I think you're probably right about the people behind it because they are regular citizens who believe it and they base it on the Bible. Well, yeah, I mean, religion is, we have people in our group who are great scientists. We just gave a person a Lifetime Achievement Award because he deserved it, because his model of the atom can predict all 3,000 isotopes. And I've never seen anything like that. And that's worth it. But he's a creationist, and he claims that the Earth is 6,000 years old. I don't listen to that part, and he doesn't come to our meetings and do that. That's one of the things, the reason this is the best, our organization is the best on the planet, because we say, we don't care what your religion is, we don't care what your orientation of politics, all we care about is you get up there and you talk to us. In fact, the biggest amazing thing about our group is that when a person comes up and stands in front of us and talks science, we don't care if we have literally, our chief scientist has a PhD from MIT. She's a woman. She got her PhD in physics and special relativity, who now believes that special relativity to be wrong. She's up there giving a talk. Her talk is no more or no less listened to than the ex-Supreme Court Justice talks on Ether, who never was trained in physics ever. And he's in our organization participating all the time, writing papers. That's the way life should be. You know, that's the way really the life should be. The uniform redshift in all direction also makes the Earth in the center of the universe. That's well, you know, you're going to have people latch onto things. The creationists like the Big Bang, of course.
They have the right to think that. When they come to our organization, the CMPS has explicit terms, and they all abide by it. We do not accept papers on religion. We don't accept papers on conspiracy theories. We don't accept political papers. We've had only to ditch a couple of them. One was on the physics of the buildings coming down during the attacks in 9/11, and I said to the lady, "Can you take out this idea of the automatic blasts, supposedly that I have a degree in architecture. What happened to those buildings are easily simulated just by them coming down. I mean, the pressures that they come out, they come flying out at exactly those points on the. That's where the air is coming out as you pancake it. It comes out on the exact part of the floor which is weakest. But so that lady I said, can you take that part of it out and just talk about the physics? She said no, so we had rejected her paper. So the most important thing for all, I would say to all of you, is make sure you do not worry about whether or not that paper is on a creationist who said it, or whether it's a person who believes in UFOs. What you have to look at is what they're saying. I don't care if this guy who can show a model for every isotope that's ever existed and no one else can do it. He deserves it, even if he thinks the Earth's 6,000 years old. He doesn't sit there and talk about it or write about it in our organization, but he has a sub-organization where they talk about it. They have every right to do that. If we do it, if we cut anybody off, that we are being as bad as anybody. So, let's see, or maybe there's another explanation for all this. Yeah. Oh, Reddick, I can talk about the redshift. If that's your question? But the redshift is pretty easy. In this, you can think of it. The redshift is the reason the Big Bang was postulated. First of all, the Big Bang was named as a derogatory name. Somebody, Frank Hoyle, I believe. I think you can almost quote me on that because it was at the conference. Was the one who came up with the word Big Bang. He made it up to say like zipper zapper stupors theory. That's what it meant. Stupid theory. And the Big Bang was to be derogatory. That turns out, well, the Big Bang was postulated because they saw redshift in all directions. So they thought redshift is like, what is redshift? Well, what happens is if light's normal, you're going to see it normally. If it shifts to the red, it means it's moving away. So if you hear an ambulance go by you, that's the Doppler effect. Why? Is because as you go by, the waves, the distance away, because it's moving, the waves that come off the sound thing that's moving makes the sound waves get larger, and so it goes down as it passes you. Well, the idea is that's what happens. The idea is that the redshifts we are all seeing coming away from the Big Bang is something that comes from all the universe expanding, and that's where they came up with this whole idea of the Big Bang. If it's expanding, then it's a Big Bang. No, don't worry. I'm not accusing you of Reddick. I'm just explaining for those people here. What happens is that there's other explanations for that. Here's the problem. Why are we in the center? Why is it that the Earth happens to be in the center? And some people claim that religiously as that we are a special place in the universe. They can say that the Big Bang is a theory. But the explanation is, in 1999, Dr. Karzani was invited to speak at an astronomy club on Long Island. I accompanied him because he was my mentor, and I accompanied him. And in 1999, they were talking to an astronomy club, not physicists, astronomy club, who had already argued away all the redshift, saying this is just part of light. This is a normal thing of light. It has nothing to do with things moving. It's just light. And that they said the only one they couldn't argue away was the one between galaxies. This is amateur astronomers. Astronomers, let me tell you, are not fans of particle physics, theoretical physics. You know why? They don't trust anything you can't see. Astronomers say, if I can't see it with my telescope, you can tell me all you want, but let me point to it and let me look at it themselves. That's why they're much more critical thinkers. But it turns out that the redshift can be light. Here's the easy explanation I can give, and this comes from Borchard. And he says this, that is, in the universe, there's really almost no empty anything. There's always stuff there. But even at all levels, there are no partless parts. That is, no part can have there is nothing. You can't find something that doesn't have parts, that you can't divide into parts. But infinitely, the universe goes out for infinity. Just goes on forever. And there's things forever. I know it's hard to maybe accept it. It's a lot easier to accept than parallel dimensions. Get out of here. That's ridiculous. So what happens? If you have light and it is moving, light is a thing. The idea that light isn't a thing, it burns the heck out of you. You can't say that it's magical. It's not magical. It's a thing. And in our model, it's particles coming at you in waves. The same particle that causes gravity that pushes on you like this. This is gravity pushing on you. And our particle model says if the particles of gravity are hitting you in waves like bombers, if I do this, if I take a piece of metal like this and I keep bending it in way, if I push on it, it probably will never break. But if I bend it, that's why light, but it's a physical thing. Regardless, just imagine this. Our explanation as critical thinkers, why there's redshift. Light cannot go on forever at the same speed without colliding into something or going around something. In fact, light waves do bend. Take a prism, it bends. Well, the reason it bends we can explain, but so it's not going to go straight. And if it's not going to go straight, things are going to change. Its speed's going to change, or its wavelength. So if those things are going through, that wavelength can shift. Some people call it tired light, is to put it in colloquial terms. So the reason there's redshift is because that light, it's part of the way light works in the universe. So everybody, if you were to go a trillion, let's say 30 billion light years away, and you'd stand on a planet there, you'd see redshift in all directions because that's the way light works. That's our explanation. It's easier to imagine yeah, absolutely. Reddick, I agree with you 1,000%. You find it easier to imagine an infinite universe than a finite one. Well, this is the problem. Gravity is a field. It's a field in the sense of it's not a magical thing that's it's a field of a lot of particles going all around. And the reason you have gravity is if you have two things together like these two mice, if you have them going all around like this gas or things going all around directions, this one's going to block some of them that aren't going to get to this one. And if that happens, guess what happens? There's less pressure here. They come together. It's called the shadowing effect. Well, that kind of thing, if you get to an edge of a universe, it all falls apart. If you come to an edge, it all falls apart. If you come to an ultimate particle, it all falls apart because particles don't magic unless you believe in a magic. The ultimate particle has to now have charge, and it has to have spin, and it has to have color, because it's going to have to start organizing itself. It can't. So infinity all the way up and down in the sense of macro and micro, but also in all directions. Yeah, it's much easier than lots of dimensions. And in fact, there are infinite little worlds everywhere. They just have a real place. The difference is that they don't have, in quantum mechanics, you have like a Dave DeHilster right here next to me in another dimension. And there's like different universes now, multiverses. Get out of here. Yeah, I mean, inside this is a sort of a universe. It's a part of the universe. The universe is everything. But inside there's there's infinitely down, all the way down. So there are probably intelligent beings in here, or way down. It keeps going. It's scary, but that's like, you're right. That's a better thought than the things that we have today. Infinity is one of the courses we're going to have in our university. Okay, we'll see you later, Lisa. I'll see if people want to stay around. We got 9 watching. So, well, I really appreciate everybody coming by. I was worried, and even having people come and ask questions. I didn't even have anything prepared. Let me take a look at some of these other questions. Thank you so much, Lisa. It's wonderful having you aboard. Please do not go away. I'm going to make you my customer, as we say. You're going to be my customer. We're going to make you, if you can understand it and it's written down, you're going to help us do that. Maybe you'll even, you're going to become an expert. Watch out. And the next thing, you'll have your own YouTube channel. That'd be wonderful. Okay. How many primary forces? Good question, Reddick. In our model, in our universe model. Where is it? Right here. Real old book. This is the old one. Universe Hack, Particle Model of the Universe. You know how many forces there are? 1. That's it. The only thing that exists in the universe are particles that hit each other. And the whole universe can be made from that. So the weak force, in fact, it turns out that the latest data from particle physics, they don't broadcast this, has shown that there is no strong force. There's no strong nuclear force. Sorry, doesn't exist. So basically, the number of forces in the universe, we only have um, uh, momentum. I mean, momentum, kinetic energy. That's all we have. Our entire model can be, in fact, light works that way, light bends that way, right? Refraction. And our model so far is beating out other models that I've seen. Ether models are the most popular model by far. My father and I, and only a few other people who are our friends, are on our model. But I'm not here to say, oh, we found a model. But the model we stumble upon between my father and I, we can't break it. And so far, the only thing that it is are particles hitting each other, and it's working quite nicely. So, according to our model, there's only particles in movement. Are there two charges or simple charge? No, charge doesn't exist. And I'll tell you why it doesn't exist. Go and see my video on that. Charge, I'll give you, let's take this example again. Let's take these two things here. Yonel Dinu, again, you look him up, Ioneldinu, Yonel Dinu, and you look under his underwater experiments. What happens is, in our model, electrons, magnetic fields, light, gravity is all the same particle, G1, because they all travel at the speed of light, they're the same particle. So they move around. And what looks like charge ultimately is a reason we put a plus on this and a minus on this, and they come together. That's why we have charge. That's why we sort of invented it. And in fact, Benjamin Franklin, believe it or not, I think was the man who invented charge. If you go and look at go look up dissident science charge. There's no charge. I don't talk about it. So charge is just is a plus and minus we put on, and in our model we can explain all of it without charge. Electrons go around the nucleus not because they are negative and the nucleus is positive. It's because a level below, think of it this way, our model's simple. It's the planetary model because it's all gravity, really. Basically, electrons go around, or G1 particles, gravity particles, G1, we call them electrons, the same thing as electrons. There are a lot more of them than just one. That's the reason why we see atomic structure a little different. That was part of the thing that I put into the model. But basically, they go around because there's a G2 particle a level down that goes at c squared, and c squared appears in E equals mc squared. Well, the reason it appears in E equals mc squared, that's only one particular thing, is because the G2 particle below it is going so fast, is going at c squared, an immense amount, and those keep the little electrons good. So it's not positive and negative. Charge is not a fundamental thing. It's a convention. It's a convention, and we describe all that stuff without charge. Okay, how does your model explain electricity? You need to, Reddick, please. Go to youtube.particle.guru. youtube.particle.guru. My dad is explaining everything you're asking about in the particle model. He's the particle guru. He's talking about that, and you will see. Again, we need to get our book out there, so that's something that we need to get out, obviously. We also have a channel for it. I just haven't had the time to come up with that. We got 6 people watching now. We were up to 9 or 10 at one time. If there are any more questions, if not, we're coming up to about an hour and a half, 90 minutes, and I can certainly stop this. I do appreciate all you coming, and great. Let's see. I'll have to spend some time learning about the G1, G2, yeah. We got probably get once in a while we get the G3. But basically, in our model, there's only 2 particles right now that do pretty much everything in the universe, and it's working. It even explains the double slit experiment with the detector. We know what happens with the double slit is you have particles or light or electrons. In ours, it's the same. Guess, oh, that's a surprise. And they go through, and if they turn the detector on, it looks like particles. If you turn it off, it looks like waves. Well, the reason is that the detector, when you turn it on, has a magnetic field. The magnetic field is G1 particles. The G1 particles have mass, just like anything else, and the things that you're shooting through are G1 particles, and so you're changing the G2 gravitation. So imagine you have gravity that keeps the planets going around the sun. You have a gravity a level down with a particle at the next level, where the suns are like the nucleons. We call them nucleons because they're not positrons; they're just nucleons, and they are probably made up of even tinier atoms. And those things are sitting there, and the G1 particle goes around that. And the reason it goes around, it's got a G2 particle making a field for it, and it's doing it too. So the strong nuclear force, if you were to say, is actually the G2 particle. But it's all the same thing. The same principles that work for gravity work for electricity, work for electronic components. But my dad will explain all that. You really need to. My dad explains it way better and much more organized than I do. He thinks about. My dad is a wonderful explanation guy. I'm very lucky to have him as a person working on a theory. That's bizarre. If this ever turns out to be anything, then maybe it'll be an interesting story. But okay, any other questions from anybody here? Oh, I think this has been great. I hope I think maybe people are gonna watch this, are gonna find this pretty interesting, maybe. But I really do appreciate it, and keep your mind open. Don't believe anything we're saying. Find out yourself. You know, I'm talking about the particle model. The only reason, I'm going with it because my dad discovered the big breakthrough, which was the particle wave duality. That actually light or waves are waves of particles. You know where he got that from? Fiber optics. You know how we do fiber optics, send information digitally? We send waves of waves. We send waves of particles, basically, if you think it, even if they were photons. But a light wave can't be one particle. A light wave has to be many particles coming in waves of particles. So it's working out well. My dad and I at times, we don't know if it's real, but the problem is it's working out. And the thing is with the G2 particles, it may be very possible. I did some calculations. If we can find a way to use G2 particle waves, the G2 particle waves, they travel at c squared. That certainly would get us communication to Mars. I calculated in about a fourth of a second. We could communicate directly to Mars at a fourth of a second delay. That would be pretty interesting. And if they could do it using our model, great. Thank you, Dave. Thank you, Adam. Thank you, Eric. Thank you, Lisa, and everybody else who was there. I know there are 6 watching. Thank you so much. I am going to stop this now. It is 11 o'clock my time. If you think this is valuable, then I'm planning to see if we can do this next week. Do you guys have any feedback that this is sort of a good format? Maybe try it on Fridays or once every couple Fridays, or what? What do you guys think? Anything? It takes a few minutes, a few seconds to get there. I think the delay can be as much as 10 seconds, so 20 seconds at least. So I'm waiting. People dropping off, then But nope, still 6 people there. You guys liking this? Yes, no, thumbs up, thumbs down. Well, you can always put it in the comments. Alrighty. Thanks so much, Adam and everybody. Take care, and as I always say, stay critical, stay thinking. I'm Dave D. Hillstrom, your science therapist. That's what I really am. My friends think that. Okay, all right, that's good. If you guys want to tune in, I think we'll give it a shot. And I think if people watch this, maybe they'll find it valuable, because having the question answer session I found works really well with my friends, and they keep bugging me. Every time I go to a party, that's the way it is. Hey, Dave, I read this article. What do you think about this? And you know why like I said, they like the answers because we are critical thinkers, and we've actually thought about this for a couple decades. So, and what would be really cool is to see you guys eventually be contributing to all that, and see you at a conference sometime. Okay, ciao for now.